Open Windows 11 and click the search box in your taskbar. Type the name of a file buried somewhere on your hard drive. Within milliseconds, that file appears alongside emails mentioning it, settings related to it, web results about it, and suggested actions you might take next. This is not a simple file name lookup. This is semantic understanding, contextual analysis, and increasingly artificial intelligence, interpreting not just what you typed, but what you probably meant. Recent updates to Windows 11 have fundamentally changed how Search Opera tests, transforming it from a basic file indexing system into an intelligent assistant that reads document contents, analyzes context, understands natural language, and in some configurations, processes your queries through to cloud-based AI models. For most users, these changes are invisible, manifesting only as faster results or more relevant suggestions. But beneath that polished interface, Windows is doing something profoundly different with your files than it was even a year ago. The question is, what exactly Microsoft changed, why they changed it, and what it means for the privacy, performance, and autonomy of your computing. Because Windows Search is no longer just finding files based on names. It is understanding content, learning patterns, and in ways most users do not fully realize, becoming the first true AI-powered component of the operating system that touches everything you create and store. Understanding what changed requires first understanding how Windows Search has historically functioned and why its architecture matters. At its core, Windows Search is an indexing service that runs continuously in the background, monitoring your files, extracting information about them, and building a searchable database that enables near-instant results when you query for something. Without indexing, searching would require examining every file on your drive sequentially, which on modern systems with hundreds of thousands of files would take minutes or hours. Indexing solves this by pre-processing files and storing structured information about them. The Windows Search Service, implemented through the searchindexer.exe process, monitors designated locations on your computer, typically your user profile directories including documents, desktop, downloads, pictures, and email stores. When files are created, modified, or deleted in these locations, the indexer detects the change and updates its database accordingly. For each file, the indexer extracts metadata, including file name, file type, creation date, modification date, size, and location. For supported file types, documents, SPREAD sheets, presentations, PDFs, emails, the indexer also extracts content, reading the text within files to enable full-text search. This content extraction is performed by filter handlers, specialized components that understand specific file formats. Microsoft Office files use one filter handler, PDFs use another. Each filter parses the file format, extracts readable text, and passes it to the indexer. The extracted content is then processed, broken into words, and indexed in a way that enables fast searching. When you search for a specific word or phrase, Windows queries this index rather than opening and reading each file individually. The evolution of Windows Search reflects changing user expectations and technical capabilities. Early Windows versions had primitive search that simply matched file names. Windows Vista introduced Windows Search 4.0 with the first truly functional indexing system, though it was plagued by performance problems that consumed excessive CPU and disk resources. Windows 7 refined the indexing engine, making it more efficient and less intrusive. Windows 8 and 10 integrated web search results alongside local results, controversial among users who wanted local-only search. Windows 11 represents the latest evolution, with interface redesign, performance improvements, and increasingly AI integration. The fundamental challenge Windows Search addresses is information retrieval at scale. Modern users accumulate tens or hundreds of thousands of files over years. Email archives contain thousands of messages. Document folders contain years of work. Finding specific information manually is impractical. Search must be fast, accurate, and understand context, not just exact matches. This drives Microsoft toward increasingly sophisticated search technologies, including natural language processing, semantic understanding, and machine learning. Recent Windows 11 updates have introduced several significant changes to search functionality, some visible to users and others operating entirely in the background. The most apparent change is interface integration with Copilot and the Windows search box, now serving dual purposes as both a local file search and an entry point for AI-assisted queries. When you type in the search box, Windows analyzes whether you are looking for a local file, a system setting, a web result, or asking a question that Copilot might answer. This analysis happens in real time and determines what results appear. The indexing engine itself has been enhanced with semantic understanding capabilities. Traditionally, Windows Search matched keywords. If a document contained the word budget and you searched for budget, it appeared in results. The new semantic search attempts to understand meaning and context. If you search for financial planning documents from last quarter, modern Windows Search can identify files that may not contain those exact words, but are contextually related, created in the relevant time frame, and contain financial information. This requires analyzing document content more deeply than simple keyword extraction. For systems with compatible hardware, particularly those with NPUs or neural processing units, Windows 11 can offload some search processing to specialized AI acceleration hardware. This enables more complex analysis without impacting CPU performance. The search service can run lightweight machine learning models locally to classify documents, extract entities like names and dates, and understand document topics without sending content to the cloud. Cloud integration has expanded significantly. For users signed into Microsoft accounts with OneDrive enabled, Windows Search now includes cloud-stored files and local search results. The search box queries both the local index and OneDrive simultaneously, presenting results from both sources unified in a single interface. This requires transmitting search queries to Microsoft servers, where they are executed against your OneDrive index and results returned. Performance optimizations include smarter indexing schedules that prioritize indexing when the system is idle and throttle indexing when the user is actively working. Battery-aware indexing on laptops reduces indexing activity when running on battery to extend runtime. Incremental indexing improvements mean that only changed portions of large files are re-indexed rather than the entire file. Integration with Microsoft 365 services means that for users with Microsoft 365 subscriptions, Windows Search can query SharePoint, Teams, and other cloud services, finding content stored in corporate repositories alongside local files. This enterprise-focused feature requires organizational accounts and appropriate permissions. The search box itself has gained quick actions and shortcuts. Searching for settings no longer just lists matching settings pages, but provides interactive controls for common tasks. Searching for Bluetooth can toggle Bluetooth on or off directly from search results. These intelligent shortcuts use understanding of user intent to provide actionable results rather than mere lists of matches. User concerns about Windows Search changes cluster around familiar themes: privacy, performance, control, and transparency. Privacy represents the primary anxiety. Users want to understand what Windows is doing with file contents when it indexes them. The semantic analysis and AI-powered features necessarily require deeper content examination than simple file name indexing. Windows must read document text, analyze context, classify topics, and potentially extract entities to enable semantic search. This processing occurs locally on the device, but users worry about what data is stored, how long it persists, and whether any content or derived information is transmitted to Microsoft. Cloud-connected search features definitively transmit data to Microsoft servers. When search queries include OneDrive results, the query itself is sent to Microsoft's cloud infrastructure. Microsoft states that queries are used to retrieve results and may be logged for service improvement, but are not used to build advertising profiles. Users concerned about query privacy have limited ability to verify these claims or prevent query transmission while still using cloud search features. File metadata and search index databases stored locally on the system raise questions about security. The Windows Search database contains extracted text from documents, email contents, and metadata about all indexed files. If malware gains access to the search database, it obtains a comprehensive map of the user's files and their contents without needing to open individual files. While the database is protected by file system permissions, local privilege escalation exploits could potentially grant unauthorized access. Performance impact concerns persist from Windows Vista's disastrous search performance. Users worry that aggressive indexing will slow their systems, drain laptop batteries, or cause excessive disk activity. Microsoft has significantly improved indexing efficiency, but complex semantic analysis and AI processing inherently require more resources than simple file name indexing. Users with older hardware may experience noticeable performance impact when indexing runs. Transparency about what is indexed and how to control it frustrates non-technical users. The Windows Search settings are scattered across multiple locations. Some settings are in Windows Settings under Privacy and Security, Search Permissions. Others are in the Legacy Indexing Options control panel. Understanding what folders are indexed, what file types are included, and how to exclude sensitive directories requires navigating these dispersed interfaces. Common misconceptions include beliefs that Windows sends all file contents to Microsoft's cloud, that search data is used for advertising, or that AI analysis occurs entirely on Microsoft servers. These are largely inaccurate. File content indexing occurs locally. No advertising profile creation uses Windows Search data according to Microsoft's privacy policies. AI analysis can occur locally on compatible hardware, but the partial truth that some features do involve cloud queries and that no independent verification of Microsoft's claims is possible sustains distrust. From Microsoft's product and engineering perspective, improving Windows search addresses real user needs and competitive pressures. Users accumulate ever larger collections of files and emails. Traditional keyword search becomes less effective as information volume grows. Semantic search and AI-powered understanding enable users to find information based on meaning and context, rather than remembering exact file names or keywords. This genuinely improves productivity for knowledge workers managing complex information across documents, emails, and cloud storage. AI integration, particularly Copilot, positions Windows as an intelligent assistant platform rather than merely an operating system. Search becomes the interface through which users access both local information and AI capabilities. The unified search box serves as a command center for asking questions, finding files, adjusting settings, and getting AI-generated answers. This consolidation simplifies user interaction with the system. Cloud integration reflects modern computing reality. Users work across multiple devices and expect information accessibility everywhere. Search that includes cloud-stored files alongside local ones provides seamless access to information regardless of where it physically resides. For enterprise US ERs with content in SharePoint, Teams, and Exchange, unified search finding information across all repositories dramatically improves efficiency. Performance improvements are genuine engineering priorities. Microsoft has invested heavily in making indexing faster, less intrusive, and more efficient. Entity T, battery-aware indexing, smarter scheduling, and incremental updates reflect responsiveness to historical criticism about search performance. The move toward NPU acceleration for AI features addresses concerns about CPU and battery impact. Competitive pressure from Google, Apple, and other platforms drives feature development. macOS Spotlight has long been regarded as superior to Windows Search. Google's search expertise gives them advantages in understanding user intent. Microsoft must match or exceed competitor capabilities to remain relevant. AI-powered semantic search is not optional in a market where competitors are racing to integrate AI everywhere. From a business perspective, AI features justify Windows 11's hardware requirements and drive hardware upgrade cycles. New PCs with NPUs can demonstrate AI capabilities that older hardware cannot match. This benefits Microsoft's OEM partners who need reasons for users to purchase new computers. Search improvements that leverage new hardware become selling points for Windows 11 devices. Microsoft argues that improved search benefits users more than traditional approaches. Finding info automation based on meaning rather than keywords is objectively more powerful. Unified local and cloud search reduces cognitive overhead. AI assistance makes computers more accessible to non-technical users. The privacy trade-offs, which Microsoft contends are minimal given local processing and policy protections, are justified by functional improvements. Windows Search's evolution toward AI-powered semantic understanding represents a broader transformation in how operating systems organize, access, and present information. The traditional file folder document hierarchy is giving way to content-centric interfaces, where information is retrieved by meaning rather than location. This shift has profound implications for how we interact with computers and what computers know about us. Semantic search enables natural language queries that traditional search cannot handle. Instead of remembering that budget document is named Q3, financial planning, final V2 or XLSX, and searching for that file name, you can ask, show me the budget spreadsheet from summer, and have the system understand what you mean. This requires the search engine to understand temporal references, recognize document types, and match semantic meaning rather than exact strings. Machine learning models trained on vast data sets enable this understanding, but they require processing power and, in some implementations, cloud connectivity. The progression toward conversational AI assistance integrated into search represents the next phase. Rather than searching and then opening results, users will increasingly ask questions and receive synthesized answers drawn from multiple documents. What were my total expenses last quarter? Could query multiple files, extract relevant numbers, perform calculations, and present an answer without requiring users to open files manually. This transforms search from retrieval to analysis. Privacy implications grow as search becomes more intelligent. Systems that understand content well enough to answer questions about it must analyze content deeply. The more the system knows, the more useful it becomes, but also the more it represents a comprehensive map of user information vulnerable to exploitation if security fails or if the vendor uses data beyond stated purposes. The dependence on AI raises questions about interpretability and trust. When search results are determined by machine learning models, users cannot easily understand why specific results appeared or verify that results are complete and unbiased. Algorithmic opacity, the inability to inspect how decisions are made, becomes a feature of basic operating system functionality. Cloud dependence for advanced features creates vulnerability to service outages and requires persistent connectivity. As search capabilities increasingly assume cloud processing, offline functionality may degrade. Users in low connectivity environments or those who prefer offline operation face reduced functionality. The trend toward AI integration in search is industry-wide, not Microsoft-specific. Apple's Spotlight is gaining machine e-learning capabilities. Google's search expertise is being embedded into Chrome OS. Linux desktop environments a RAI exploring semantic search. The future across all platforms involves operating systems that understand information content rather than merely cataloging files. Windows Search has evolved from a simple tool that matched file names into an intelligent system that reads your documents, understands their meaning, learns your patterns, and increasingly uses artificial intelligence to interpret what you need before you fully articulate it. This evolution is not sinister. It is the logical progression of search technology, responding to information overload and user expectations, shaped by web search engines that have been understanding intent and providing direct answers for years. But the migration of these capabilities from web search, where users expect to interact with cloud services, into the operating system, where users historically expected local private operation, represents a fundamental shift in the nature of personal computing. The changes Microsoft made to Windows 11 Search are individually defensible. Semantic understanding genuinely improves result relevance. Cloud integration genuinely provides access to information across devices. AI assistance genuinely makes powerful capabilities accessible to non-technical users. But collectively, these changes transform the operating system from a neutral platform that executes your common ideas into an intelligent agent that interprets your intent, accesses your information, and mediates your interaction with data. The question is whether this transformation serves users or merely serves Microsoft's strategic imperative to embed AI throughout their products, regardless of whether users want it. The future that Windows Search points toward is one where operating systems understand information rather than simply storing and retrieving files, where natural language replaces structured queries, where AI assistants synthesize answers from your documents rather than presenting lists of files to open manually. This future promises efficiency, accessibility, and power. It also promises dependence on AI systems we cannot fully inspect, cloud infrastructure we do not control, and vendors who know the contents of our computers more comprehensively than ever before. Whether smarter search means greater convenience or greater dependence on AI is not a question with a universal answer. It depends on your needs, your trust in vendors, and your willingness to trade local control for cloud-powered capabilities. But what is certain is that search is no longer just about finding files. It is about whether your computer will remain a tool that obeys your commands or become an assistant that interprets your intent. And once that transformation is complete, going back to simple file search will feel as archaic as returning to a command line after experiencing a graphical interface. The question is whether we will have chosen this future deliberately or simply accepted it because Microsoft made it the default and most users never changed the settings.